Good afternoon, ladies and gentlemen. I want to talk about something that's super important. It's called parent functions. And I'm just going to go kind of quick and fast through this. And our learning target is I can identify transformations of parent functions and I can name functions by the graph. So there's a lot. These first two right here, these first two right here, you probably have seen them. This guy's a constant function, f of x equals a. And this one's the linear function. Now, when you look at these two guys, a few things you want to talk about is the domain and range of both of these is all real. There is, there's no extreme values. There's no maximum or minimum because they do go on forever, right? So we'll talk, in more detail about the increasing interval. The other one is the absolute value function. Now, the absolute value function is pretty interesting because its domain is all reals, but its range, if you look, the range, it never dips below negative. So its range is all positive, or excuse me, um, all non-negative real numbers. Okay, it has an absolute minimum. It's going to reach the smallest value when you're looking at its main parent function, which is f of x equals x. Another one I want to talk about is the quadratic. The quadratic function is in the form f of x equals x squared. It has the exact same domain range as the absolute value function. It's kind of, they're like cousins. The range is all reals and the domain is all reals and the range is all non-negative real numbers. Um, it has an absolute minimum, right? That's the quadratic, and we'll get to more details on that. Another one next to it is a cubic function. That's parent function is f of x equals x cubed. This one's nice because its domain and range is all reals because it's an odd function and it's an odd powered polynomial as well. It has no extreme values. It has no extreme and no maximum, no minimum, anything like that. It does have relatives though. It does have relative max and relative min. The next one we'll talk about is f of x equals square root of x. This domain is anything bigger or equal to 0, and its range is also anything bigger than or equal to 0. So non-negative real numbers. It has an absolute minimum, right? So that makes sense. The other one, its inverse is called the cube root function. Its cube root function, the domain and range of this guy is all reals, and there are no extremas, but there is relative max and relative min, right? And the other one, so we talked about this guy, we talked about that guy, that one, this one, that one, and that one, and that one. We have a few more to talk about. Let's talk about what's called the reciprocal function. That's this guy. This graph right here is called a hyperbola. And now this domain is really it's anything it wants to be except for 0. Because if I put a 0 right here, cannot be done. So its domain is all reals except 0, and its range is, if you look, it's not, the output is approaching 0 here and it's approaching 0 here, but it is not. So its range is also not 0. There are no extremas. This guy is unique. It's, again, its domain and range are kind of goofy. That's called your reciprocal function. And then over here is what's called the exponential. That's in the form y equals a to the x. This is neat because its domain is anything it wants. It goes in both directions. The x direction goes in both directions forever and ever, so its domain is all reals. However, its range, it never drops below the y equals 0 line, so its range is anything bigger than 0. That's the exponential, so we covered that one. Another one is this guy right here. You probably didn't get to this in advanced algebra 2, but the logarithmic function, f of x equals log x. Now, this has a log base a, but typically we use the base 10. Its domain is the inverse of this guy. Its domain is anything bigger than 0, and its range can be whatever it wants. All right. I know I skipped a couple other ones, but this guy right here, this one's pretty cool. This one's called the greatest integer function. Some call it the step function. This is unique because its domain is whatever it wants to be, and its range can only be integers. It can't be halvesies or fractions or decimals. So its range is only the integers. Okay, and we'll talk more about this in the days to come. So we got those guys. There's a few of those. Let's see, what else do we have? Oh, these two right here, this one and this one, we're going to talk separately about. We're not going to talk too much about the tangent function, but all three are called trigonometric functions. But the sine and the cosine function, the sine and the cosine function both have domains that are all reals, and their ranges are, if you look, it reaches a high or a low, boom and boom. So its ranges are between -1 and 1 inclusive. And we'll talk more about this in a little more detail. So we cover that one and that one. I'm leaving out the rational one for right now. I mean, that is an important one, and you can see that one, but that's not like, it doesn't come up too often, but that's called a rational function. I just wanted to have a really quick, super quick video with you about the parent functions. And then the other thing I want to talk about is transformations. When you talk about transformations, you have a few things with the transformations. You have several types of transformations. You have what's called a rigid transformation, and you have what's called non-rigid transformation. Now, what's the difference between a rigid transformation and a non-rigid transformation? So a rigid transformation changes the position or the orientation. So examples of a rigid is a translation, which is a slide, or a reflection. So again, rigid transformations, what do? Rigid transformations change the position or orientation, right? So again, that is reflections and translations. Non-rigid transformations, what they do is they distort the shape, and they distort the shape by changing its size. So a dilation is, a dilation is an example of a non-rigid transformation. Now, when you have, a translation is a shift, so you can shift the left or right. A reflection is a flip, and that is, we talked about that, it goes with reflection with the x-axis or the y-axis. When you talk about the non-rigid stuff, that is pretty much a vertical or horizontal dilation. That would be a compression or a stretch. These are very easy. You've dealt with them before, but I just wanted to kind of touch on them today before we get into what we have to get to in the days to come. So hopefully this makes sense. Hopefully you kept up with the information. We'll have more time to deal with this in class, and I look forward to seeing you in class. And may the force be with you.